In this video, we're going to be looking at some of the free response questions from Chapter 3. Our first question says that the area of a 45-45-90 right triangle is increasing at a rate of 3 square centimeters per second. At what rate is the length of the hypotenuse increasing when the hypotenuse is 10 centimeters long? So here I've got a question asking where I'm given a rate. I'm given this rate of 3 square centimeters per second, and then the question asks me to find another rate. These are the signs that this is a related rates question, and so we're going to take our FWGI approach to solving this question. First of all, F stands for find. They're asking me to find at what rate the length of the hypotenuse is increasing. So I think I'm going to call that dH dt. W stands for when, and we want to find this rate when h equals 10. The given rate is the rate of the area of the triangle, and since that's the rate of area, I'm going to call it dA dt, and that's equal to 3 square centimeters per second. And so now we need an equation. So I'm going to come over here and let's draw a diagram of our scenario. There's my hypotenuse, and since this is a 45-45-90 right triangle, I know that the two legs are equal to each other. So for now I'm going to label them with an X. Now the equation here needs to relate area and the hypotenuse. And so I'm going to be using the area of a triangle. And for what I have so far in this diagram, area is equal to 1/2 base times height, in this case x times x, so 1/2 x squared. But this is not going to work for me in terms of my given information. I need to have my equation involving h and not x. So we need to figure out what x is in terms of h. Now if you remember your special right triangle relationship from geometry, that could be helpful here, the 45-45-90 triangle. But if we don't remember it, we can still figure out the relationship by using Pythagorean theorem. X squared plus x squared equals h squared. So 2x squared equals h squared. X squared is h squared over 2. And then finally I can square root both sides, and x is equal to h over the square root of 2. And when I square root both sides here, I don't have to do plus or minus because I'm looking for a length of a triangle. So it has to be the positive. So now I know how x is related to the hypotenuse. So I'm going to come back up here and rewrite my equation. Area equals 1/2, and instead of x, I'm going to put h over the square root of 2 squared. And so now I'm ready to take a derivative, except I think I'm going to simplify this a little bit before we do the derivative. This would be 1/2 times h squared over 2. And so really what I have, area is equal to h squared over 4. So now let's do our derivative. Sorry about that. The derivative of a, dA dt, equal to the derivative of h squared over 4 is going to be 2h over 4 times dH dt. And dH dt, that's what I'm looking for. So I'm going to substitute in for the other numbers here. dA dt is equal to 3. And 2 times 10 over 4 times dH dt. So let's see, 2 times 10 is 20, divided by 4 is 5. dH dt equals 3. And let's see, I'm out of room here. We'll write answer over here. dH dt is equal to 3 divided by 5. And then my units here, since it's the hypotenuse over time, it would just be centimeters per second. All right, let's move on to our next question. Question number 6, we have this piecewise function, And the first part asks us to show that f is continuous at x equals 0. So here we need to use the definition of continuity. First thing I'm going to do is show that the limit exists. And to do that, I need to show that the limit from the left is equal to the limit from the right. So the limit as x approaches 0 from the left of f of x would be equal to, and if I'm approaching 0 from the left, then that means that x is less than 0. So I'm going to plug in 0 to this first piece of the function, e to the negative pi times 0. Which is e to the 0, and that equals 1. Now let's find the limit as x approaches 0 from the right of this function. And if we're approaching 0 from the right, that means x greater than 0. So I have 1 minus sine of pi times 0, which would be 1 minus the sine of 0, and the sine of 0 is 0, so 1 minus 0 is 1. And so we've shown that the limit from the left and the limit from the right, they both equal 1, and so that means that the limit as x approaches 0 of this function is equal to 1. Now we need to show that the value of the function exists, and the value of the function at 0. And if I look at my piecewise function, 0 is included in the top piece of the function. So e to the negative pi times 0, again, would be e to the 0, which is equal to 1. And so the value of the function exists, the limit exists, and finally we just need to say that those two things are equal to each other. And so we've proven that this function is continuous at x equals 0. All right, the next part of this question asks us to explain why this piecewise function is differentiable. Now, if it's differentiable, that means that the derivative of each piece, that those are going to be equal to each other at 0. And so to answer part B here, we're going to find f prime. Whoops. Okay, sorry, my slideshow is going crazy here. Here we go. So f prime is going to be equal to, first of all, the derivative of e to the negative pi times x. And so, actually, let's erase this. Let's do the little chain rule charts first. I have e to the something, and so we're going to do that as a chain rule. E to the something, and that something is negative pi x. So the derivative of e to the something would be e to the something, and the derivative of negative pi x is negative pi. And so I end up with e to the negative pi x times negative pi. The derivative of the second piece, 1 minus sine pi of x. Of course, the derivative of 1 is just 0, but I need to find the derivative of negative sine of pi x, and so we're going to do another chain rule. It's sine of something, and the something is pi x. The derivative of sine is cosine, and I'm going to keep that negative there, so negative cosine of something, and the derivative of pi x is pi. And so that derivative, negative cosine of pi x times pi. So those are my two derivatives, and if I plug in 0 to my first piece here, e to the negative pi times 0 times negative pi, the first part is just e to the 0, which is 1 times negative pi, which equals negative pi. And if I plug in 0 to my second piece, negative cosine of pi times 0 times pi. So I have cosine of 0, which is 1. And so this becomes negative 1 times pi, which is, of course, negative pi. And so we've shown that at x equals 0, that our derivatives are equal to each other, and so therefore this function is differentiable. Part C here asks us to write the derivative as a piecewise function and find the smallest value where f prime is 0. So in the previous part we figured out our derivative, so let's just write this as a piecewise function. This is going to be negative pi times e to the negative pi x, and that piece is still for x less than or equal to 0. The derivative of the second piece was negative pi times cosine of pi x, and that is for x greater than 0. So if we want to find the smallest value for which our derivative is equal to 0, first of all, let's think about this first piece, negative pi times e to the negative pi x. If you think about the e to the x function, you'll remember that it is never equal to 0. And so if we're looking for the smallest value where our derivative is 0, we don't even need to consider the first piece because it's never going to be equal to 0. And so that means I'm going to just take my second piece, negative pi cosine of pi x, and set it equal to 0. And if I divide both sides by negative pi, I get cosine of pi x equal to 0. And so now I'm thinking to myself, where is the first time that cosine is equal to 0? Well, and that of course happens at pi over 2. And so that means that my angle here, pi x, needs to be equal to pi over 2. And if that is the case, then x is equal to 2. Last part of this question, write an equation of the line tangent to f at x equals 0. So for our tangent line, first thing I'm going to do is write down our formula for the equation of a tangent line. Y equals f of a plus f prime of a times x minus a. And remember that our a value here, we're writing the equation line at tangent line at x equals 0. So I need to find f of 0, which was equal to e to the negative pi times 0, and that was equal to 1. Then I also need f prime at 0, so that's going to be equal to whatever we get by plugging 0 into the first piece of our derivative. So negative pi times e to the negative pi times 0, and e to the 0 is 1, times negative pi would give us negative pi. So now I have everything I need to write that tangent line equation. Y is equal to f of a, which is 1, plus f prime of a minus pi, times x minus a, which is 0.